Recall all of the exponent rules from Chapter 5. Those would be found in Section 5.1. And first we had the product rule. So if you multiply the same base, a, then you keep that base and you add the exponents. The power rule, if you raise the base a to a power to another power, then that base a stays and you multiply the powers. The power of a product, if you have a product raised to a power, then each factor of the product gets that power. If you have a quotient raised to a power, then each part of the quotient gets that power. The quotient rule, if you divide the same base, you keep that base and subtract the exponents. My favorite is the zero exponent rule because anything raised to the 0th power is 1. And finally, the negative exponent we just talked about. Any base raised to a negative exponent is 1 over that base to the positive exponent. So we're going to use these rules and properties of exponents to simplify expressions. Always you should have positive exponents only in your final answer because that's the only way to be simplified. So our first example, a, I've got a quotient of base 9. So I'm going to keep that base and subtract the exponents. Always the numerator minus the denominator. Okay, so that's going to be 9. And if we subtract those, 2 minus 12 is negative 10. So negative 10 fifths altogether. And of course, remember, we have to simplify if we can that rational exponent, so that simplifies to negative 2, which means we just move that base so that it has a positive 2 exponent. And 9 squared is 81, so that final answer is 181st. In example B, I'm multiplying the same base, right? That's a multiplication symbol, so I keep that base and I add the exponents. Negative 3/10 plus 6/10. So since they have the same denominator here, I'm just going to add the numerators. Negative 3 plus 6 is positive 3. And that is simplified. And it's a positive exponent. And that's all I can do to simplify that then. For C, 11 to the 2/9 to the 3rd. So that's a power rule, base 11. Multiply the exponents, 2/9 times 3. So we're going to multiply numerators, multiply denominators, and simplify. So since 9 is 3 times 3, I can divide a factor of 3 from both the numerator and the denominator. And I don't need a 1 because I already have another factor there. So in the numerator, that leaves 2. In the denominator, that leaves 3. So 11 to the 2/3 power is a simplified fraction exponent. So that's as simple as that gets with a positive exponent only. D, I've got in the numerator a product to a power. So I have to give each of those factors that power in the numerator. So 3 gets that power of 3. And x to the negative 2/3 also gets that power of 3. So then we want to simplify what we have up there in the numerator. 3 to the 3rd power is 27. And x to the negative 2/3 to the 3 means that we have to multiply that. That's the power rule there. So if we multiply numerators, multiply denominators, we can cancel out a factor of 3 there. So that leaves us 27x to the negative 2. That's all that's left for the exponents there. And then I do have a quotient of the same base, so I can do the quotient rule, or I could do the negative exponent rule first. Doesn't matter. I'm just going to do the quotient rule. So x to the negative 2 minus 2, we subtract the exponents, which is going to be a negative 4. But now I do have to have positive exponent only, so I'm going to have to move that base x over the fraction bar so it has a positive 4 exponent, and 27 remains in the numerator because it does not have a negative exponent. And that would be my simplified expression there. Then we have some multiplication. also from chapter 5, I think 5.3 would be the section there, multiplying polynomials. So this is a monomial single term times a binomial. I'm going to distribute. So I'm going to multiply x to the 3/4 times x to the 1/4. And then another term, I'm going to multiply x to the 3/4 times negative x to the 3rd. Okay, distribution. So then I have to do the multiplication here, multiplying the same base. So I keep that base, and I'm going to add the exponents. And the next term, those are opposite signs, so that'll be a negative base x to the 3/4 plus 3. Oh, this is getting interesting, huh? So I can just add 3 plus 1 here, which is going to be 4/4. But here I don't have the same denominator, so I need a denominator of 4. I'm just going to multiply 4 over 4 to that one. So that's going to be 3/4 plus 12/4, same as 3. And then I can add the numerators. So 3 plus 12 is 15/4 altogether. And if I can simplify, remember the fraction has to be the simplified form, so that first is just 1, and I don't need to write an exponent of 1. And 15/4 can't be simplified. They don't share any factors. So that will be my final answer for this product here. For example B, this is a binomial times a binomial, so we're going to have to distribute each term to each term. So I'm going to first distribute the first term of the first binomial. So that's going to be x to the 1/4 times another x to the 1/4. Then x to the 1/4 times negative 7. Then I'm going to distribute the second term. So 1 times each of those terms. 1 times x to the 1/4 plus 1 times negative 7. Okay. So I've got 4 terms here. Let's simplify what we have. The first term is a product rule, so x to the 1/4 plus 1/4. The second term, I'll just move the negative 7 to the front, so this is going to be negative 7x to the 1/4. That third term, I don't need to write a 1 coefficient. It's understood, so x to the 1/4. And then that fourth term, 1 times negative 7 is negative 7. So then I just need to simplify that first term. If I add 1/4 plus 1/4, that's 2/4, but that simplifies to a half. Oh, and I have like terms here. So like terms, x to the 1/4, same variable, same exponent. Just add the numbers in front. Negative 7 plus 1 is negative 6. X to the 1/4 all together. So that completes the simplification for that product. For this next example, we want to factor x to the negative 3rd from this binomial expression. So factoring, that would have been 6.1. In chapter 6, we started in this class with factoring polynomials. So if I want to factor, that means to write as a product. So if I want to write this as a product, the only way I can do that is to also divide what I'm multiplying here, right? Like if I was multiplying by 5, I have to divide by 5. I can't just multiply by a number because it will change the value of the expression. I have to also divide that number so that the expression remains equivalent in value. Okay, so keep that x to the negative 1/3 in front, and then let's simplify what remains of this binomial here. So 7 divided by 1, that leaves 7 for the number factor. If I divide x to the negative 1/3 by x to the negative 1/3, that's 1. So that cancels out multiplicatively. Then the second term, 5 divided by 1 is 5. And if I divide the base x, I subtract the exponents. So 5/3 minus negative 1/3. Be careful if you're subtracting a negative, right? Because that then becomes plus. 5/3 plus 1/3 is 6/3, which simplifies to 2, which is nice, right? So I factored out x to the negative 1/3 by dividing it from each of those terms.